Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics.
Welcome to this episode of Speaking of Reliability. My name's Chris Jackson.
Hi, Chris. I'm Dianna. How are you?
Good. And we're going to be talking about AI in the field of reliability, which seems like a bandwagon topic to talk about, but to be fair, I think it largely is. But
well, I mean, yeah, for some really mathematical and technical people, AI has been around for a long time.
Right.
So I've heard some people say, so what's the big deal? This has been around. This isn't a big deal. And then with other people, it's something brand new. But a lot of things going on with AI, and I'm glad to talk with you about it because I think we've been doing some different projects. So I want to hear what you've been doing and the kind of things that I've been seeing too.
Yeah, well, I think firstly, AI is one of the best ways to know if AI is the right tool for you. And describing AI as a single tool is a bit of a stretch because it covers a lot of things.
Yeah.
But I think AI works the best if you and your team and your organization have the reliability and maintenance engineering basics sorted out in your head, and you use AI to enhance your pre-existing knowledge or pre-existing understanding or your analysis capabilities. Where AI, for me, just doesn't even work a little bit is for organizations, teams, people who see AI as a tool to not have to do the basics.
As a shortcut.
Yeah, just to try and get an answer as quickly as possible. That is essentially my line in the sand. If you can see it culturally, if people want to do what they're already doing faster, better, more comprehensively, and AI is a tool that they're going to use to take their skill set to the next level, that's where it can work very, very well. For those organizations who can't take the time to teach their people or focus on understanding these things these important things, and AI is a simple band-aid to say we've covered this, it usually results in terrible outcomes. That's my experience. What do you think, Dianna?
Well, I'm a process systems thinker. So with reliability analyses, I still think of them as a process, especially with checking all the assumptions that go into them, and some of the rules and when you want to use this and that. So yeah, I agree. If you have the basics down about the process, then I think you can start to use AI to create tools for you to make it easier for your work. But to just a simple input, output, and you don't know what's happening in the middle is not very good. You need at least a stepwise approach. Even when taking AI, it's not, I have this problem and it spits out an answer. You're like, I have this problem. Here's the first step. Let's figure this out. And then check the assumptions for that. So I take a process approach, stepwise approach, even when I'm prompting AI and working with it. Many steps.
Well, the other thing too is I think reliability engineering, often people think that is synonymous with reliability analysis. Reliability engineering, first and foremost, it starts with making things that are more reliable. And the analysis kicks in once you're trying to study this thing that is ideally more reliable. And so, we go to conferences and everything else, and there's AI this and AI that. And the reality is, it's you can see that people are trying to get on the bandwagon, just try and have AI in the title of whatever it is they're selling. The number of academic presentations I've seen which involve this some sort of illustration with pillars, AI pillars, and just phrasing the problems with how you deal with AI, and that represents ongoing study is not helpful, and it's just everywhere. And the number of peer-reviewed papers which essentially reframe the same perceived AI problem from a slightly different viewpoint is not helpful. I think there's precious little actual guidance on how you use AI to get good outcomes, which is stuff to make better decisions, and make sure that AI isn't doing something crazy in between.
Yeah. So can you boil down these pillars that people are identifying? If they're calling them different things, I'm sure that we've all heard them before, but I guess it'd be good to get a basic on that.
Well, I see them all the time, but they're all different. That is, let me think of. I just came back from a conference. I was trying to think of what it is because there's about 3 or 4 presentations I saw, and all the pillars were different. But one of them, I think, one key one was human involvement. Another good one was ethics. Another good one was economics. Another good one was
Oh,
testing and validation. It's just these,
so they're very high level concerns about the application of AI in
right,
general.
just sort of keywords to create an illustration without there being any so what.
Mm.
And I think like I've recently developed approach to doing a FMEA with AI. And just before people start vomiting when they hear the acronym FMEAs.
I'm okay. I'm with you.
Well, FMEAs back in the day was supposed to, their main output was corrective actions. So you're supposed to do FMEAs as early as possible to identify great ideas before you even think about designing
Yes, I'm right on
your
board
thing.
with you. Hmm.
Right. And these days, if you say, well, you should do your FMEA before you design, one of the first things people often say is, well, how can you do a FMEA on something that you haven't got a design for?
Uh-huh.
And you
Yeah,
go,
I've heard this. You're beating my drum, Chris.
yeah, it's nonsense because let's just say you're designing a military vehicle, armored vehicle, and you say, we haven't designed it yet, so what's the point of doing a FMEA? All right. Is it going to have wheels? Yes, it's going to have wheels. Will it have a steering wheel to control the direction it's driven? Yes, it will. Will it have a diesel engine? Yes, it will. Transmission? Yes. Armor? Yes. Weapon mount? Yes. Armored windows? Yes. Windscreen wipers? Yes. Um, it will have all these things, and I could keep going on and on and on, that you know are going to be part of your design before you start designing it. It's just a weaselly way to say I want to rush to designing stuff because at the start of a project where there are no delays, no cost overruns, everything's fun, no one's in
Yeah.
trouble.
Hmm.
The budget is completely as full as it's ever going to be. You got it all the time in the world. You just want to start racing to your nearest CAD software, or start coding straight away, and that's where most failures start. The rush to build the wrong thing fast, and so that's what a FMEA always was supposed to be, and every standard actually talks about that. But these days, I believe FMEAs are more seen as analyzing an existing design to see what we can improve on an existing design. By that point in time,
Yeah, or it's kind of like a checkbox to get something
right,
done, right? To have on file. And
or to
then it
get
gets put
failure rates.
away. Yeah. And then it gets filed away and nobody looks at it
Right.
ever again. Mm.
So going back to my approach to FMEA is I've got an AI approach where the very first step of the FMEA workshop is we brainstorm requirements, the humans, and then we use an AI prompt. It's about 20 pages. It's taken it's a long time to perfect. And to be honest, it's never perfect. You keep improving it to come up with help fill in the gaps, the requirements for your product. The next thing it does is the next step is functions. So one requirement at a time, brainstorm functions for each requirement. AI fills in the gaps. And what AI in particular, so I've got an AI prompt for requirements, and I've got another very detailed AI prompt for functions. And let's talk about software. I mean, no one does a really good job, no human-based FMEA workshop does a really good job of getting software involved. But an AI prompt, which can link to Anne-Marie Neufelder's common defect enumeration, for example, which is
Hmm.
just a link to every known way software can fail, well, straight away, AI is able to look at that requirement and come up with all the functions, software functions required to make that happen.
So
And
that's a great way to do it, because you have this huge database, but now you
right.
have something specific you're developing. And so the AI can take that specific step and look for the patterns that are going to match.
Yeah, and the good thing too is it can take the generic language of how every single possible software failure and use the language associated with your device. The example product I use is a smart lock, and it's until you see it, it's incredible. And then the next step, another prompt for functional failure modes and component functional failure modes, and then you can help with severity, occurrence, and detection. Each one of those, when I do it, the most important thing is human brainstorm first, and then AI takes all the documentation, everything else in the world, plus the human brainstorming effort, and spits out its outputs. But perhaps the thing I like the most about this approach too is that when it comes to corrective actions in particular, the prompt I've got, you can take in a description of your organization, what it does well, a list of people in your organization, and then when it develops corrective actions, it develops, also a schedule, your program schedule, like, design freeze or design review or launch and all those different little milestones. And then when it comes up with corrective actions, it might have, for a particular way something fails, it might have 20 corrective actions, but that sounds overwhelming. But when you look at it, corrective action number one is Michelle Smith, who's a systems engineer, specify the pin cache clearance time for the software team. And it goes through and it comes down to this, firmware team, make sure you code this, develop a state diagram. The test and development team, Billy Smith, I think I said Smith twice, you need to develop a test to ensure test for 5-second cache clearance for pin entries. And it just goes from top to bottom, where you have all these little micro tasks by date, by who needs to do it. And all of a sudden, you start generating a program plan straight away for all the things that you need to do to focus on the big ticket issues. And every step of the way, you're prioritizing the most important requirement, the most severe failures, the ones that, the hot ones, the highest occurrence and detection. It's once you tap into it, the outcome is just this extraordinarily detailed, follow the bouncing ball for the most likely ways your thing will fail, especially for software, because the biggest root cause of failure for software is hardware people not telling the software team what needs to happen.
Well, I really like this idea, and I hadn't ever thought of taking it that far, because, a lot of people think about, oh, I got this big FMEA table and I have to fill it in, and bringing in maybe the complaint register for a product that's similar or something like that for the AI to analyze for failure modes. But now you're taking it to actual actionability and having the AI to help prioritize activities based on the actual staff that you have and the actual project that you're working from. So that's a really empowering way to use AI. I like that. That's really cool.
Right. And usually, when I teach FMEAs and show them this stuff, at the start, you can tell we just want to learn how to do this to learn how to do this. But when it's done well, you actually have people say, can we do another FMEA next week? It's not that they are enjoying themselves, like it's not like it's a party during a FMEA workshop with AI. But engineers really respect productivity. And so if they're sitting in that room before they design their next thing and they're saying, oh, I would have definitely missed that. Oh, it's also got a schedule of the 20 people across the organization with all the little micro tasks that they need to do to make sure this issue is not an issue. Well, it then takes one of the biggest problems, I think, with corrective actions is it's usually one corrective action for one root cause, and that's assigned to one person, and that one corrective action might be very large in scope. And so you got this poor person trying to convince everybody else to do stuff. But when it's like this, and it's extraordinary. You have, I created a hypothetical organization of, I think, 48 people designing a smart lock for the first time with all the names of who does what, firmware teams, mechanical engineering teams, test and evaluation teams, the fracas teams. And so each corrective action might have been 20 corrective actions per root cause, for example. a lot of it's software. It just says you do this, 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 and off you go. And if you've got really strong software specifications, for example, well, AI will take that when it comes up with the occurrence score and say, okay, so this particular failure is all about not specifying, for example, a 5-second cache clearance time for your PIN. But the software specifications you fed into this prompt clearly have that there. So, okay, this is unlikely to be an issue then. So the occurrence score goes down and you don't waste your time focusing on that part of the system during your FMEA. That's the other thing too. FMEAs are supposed to be doing part of your system really well, not all of your system poorly. So that's a very tangible example for me of how AI can be used to really take the design, which is where reliability happens, to the next level.
And, I know sometimes people worry about the outputs of AI, which is legitimate, but as you continue to work with AI in different capacities and trying different things, you'll come to understand the limits of the models that you're using or which model is better for something else. But now what's interesting is I'm learning of people that they created multiple agents that are all tasked toward completing something, but maybe one of them is a quality assurance agent, or they're all programmed to kind of watch each other for the quality of the output. And as they're working on a task, they'll see the prompt ideas coming through, and the one AI agent will call out the other one. Agent A will call out B. What are you doing? You're not on task. And
Right.
agent C would say, this is taking too long. What are you focused on? So they're starting to not just use the AIs to produce an output, but also to use the AIs to check each other with the output that they give, which is also more empowering and more makes you more confident if you're applying AI to these kind of things, like you're doing with the FMEA process and generating the input for who does what on what schedule. But then have you found also that if you give it feedback, like you tried these processes, this didn't quite work, does it help you figure out a fix or a tweak to make for next time to make it better? Are you using it to help problem solve for its own self?
Well, I think for the example I just talked about, I've got some ideas on. To be honest, I want to turn this into an app which automates a lot of this stuff, and which means that part of that app would allow human corrections to be logged and identified, and we can say, "Well, why did the human change this from one to another?" But I had a little chart where I talk about the effort associated with using AI, and I have a bar or column. At the left-hand side of this, flat column, it's like a 10% of the entire column length. And so that's the human inspiration, and the rest, the 90%, is the AI perspiration. And so every step of the way, you have to find a way, for FMEAs in particular, of humans being able to review AI outputs. So, for example, when we're going through all these functions that AI developed for the smart lock, some really good stuff, especially for time budgeting, which everyone forgets about up front, but causes so many failures and recalls later on. But one for the smart lock was that when you insert the key into the smart lock, it must unlock within 1.5 seconds. Now, a time allocation is appropriate for example, when you're entering a PIN to a smart lock, you enter the correct PIN, authorization time, processing time, command time, time for the electric motor to retract the bolt. That needs to be budgeted. But when you have a key, which is being inserted to a smart lock, it is mechanically pushing, or through the transferable force, mechanically pushing the internal mechanisms of the smart lock itself. There is no time element to that. It just, as you turn the key, the bolt retracts. And so that's an example of AI messing up. And so humans can go through, say, okay, that doesn't make sense. Get rid of that one. And the analogy I use when I'm teaching AI is are you, I dare say the answer to this question is yes, Dianna, but you watched The Big Bang Theory?
Yes.
So the analogy I use for AI is it's like a drunk Sheldon Cooper. It
Okay.
is. Yeah, it's
I've heard of interns, but I like your analogy a lot too.
right. There's possibly a better one out there, but you can just imagine drunk Sheldon Cooper mixing hyper literal interpretation with focusing on things that he doesn't thinks he thinks is important, but you don't, and seeing things that aren't there, and focusing on things that interest him versus you, and so you got to learn how to dance with the beast. But the other thing too is that AI almost for every time you ask it to do anything, it almost rations out its thought process.
Yes.
Yeah. So if I put all my prompts together in one big massive prompt to do a FMEA by itself, which I'm not advocating you do for an item, it will give a FMEA output, but it will spend just as much time thinking about that output as it does if you ask it to develop a set of functions for a specific requirement. And so that means you have a very small product if you ask AI to do everything all at once, compared to asking AI to help intervene every step of the way. And that's not what engineers aren't wired to think that AI behaves that way. They almost look at AI as software, whereas if you ask a software program to do 100 things, it will do 100 things. If you ask it to do 10 things, it'll do 10 things and take 10% as long to do. Whereas AI, regardless of what you ask it, it tends to take the same amount of time to answer the question and invest the same amount of thought process. So you ask it to do everything at once, you get a very small product or output. If you ask it to help intervene every step of the way, the final output from all those steps being combined is much more comprehensive and much more insightful. So there's not a lot of that being talked about as well.
Yeah, I guess yeah, we kind of talked about that, just the proceduralized, right? If you know you need to do this step first, then this step, and breaking it down. But that's great insight, because I've seen that too, where the AIs, if you just give it too much of something to do, it does it. There is a difference in the output that you see at the end. But the more context that I give it, I usually try to give it a lot of context, and then just the opportunity to ask me any clarifying questions. It almost always asks questions for extra clarity. So breaking things down into smaller chunks and then asking it to clarify any questions for context has gotten me a lot farther than like you said, just trying to do everything at once in one prompt, one mega prompt.
Yeah, and you need to, like, again, in these prompts, going with my FMEA thing, I had to learn that I had to, in each prompt, I have to clearly define what a requirement is in my context. And so in these FMEAs, a requirement is being defined as something the customer or user is able to do with your smart lock. I walk through the door, lock it remotely, secure, just keep bad people out, all those sorts of things that engineers often rush through when they start furiously specifying performance and other things. Then the next prompt has to clearly define what a function is, and then system functional failure mode and physical failure mode and failure mechanism and faults that triggers a failure mechanism and software failure mode and software defect or entry point, I should say. And you have to, because I have this construct where all those definitions, it wouldn't work if those things weren't defined. If you ask AI to come up with the concept of what a requirement is, there's so many different ideas on what that definition should be out there that AI would, each time you ask it, it would have a guess at what it thinks the median interpretation is.
Mm-hmm.
Whereas if you want a requirement to reflect, no, I want the requirement to be essentially the language the customer would use to describe what they want to be able to do with your product, you have to define that. If you want the function to be, no, I want this to be a very performance oriented description of what the product can do to support a requirement, you have to define that. If you want to have the functional failure modes, the software, you have to define each and every one of those things. And you need to learn how to define it properly. So the language AI uses is not the same academic language or legal language. In a way, legalistic language confuses AI just as much as it confuses the layperson.
Why?
Yeah.
Anyway.
Well, it's an LLM based on.
Oh, I understand why, but it's frustrating.
Yeah.
Why? Yeah. Why make it simpler? But yeah, that's another topic.
It's almost refreshing because it forces you to explain things simply. And if you can't explain it simply to AI, you probably don't understand it.
So if you're working with just an LLM with what you have available, defining those definitions ahead of time, making sure that it understands what you're asking is really important. And
Absolutely.
they're coming up with easier ways to pre-train or to make it part of its memory. So as you're working with them, if you start to do it all the time, you can look into how to train or to give it like a glossary of terms that it can reference. But that's also really important. Yeah.
Yeah, and so my prompts, which are 20 pages of Word documents each, they have examples of don't do this, do this. Step 8's always a quality check where you say, hey, AI, if the output has any of these things, you need to have another go. It's very, you always learn. They're never perfect, but when I initially started this, I thought it would be very black and white, but it's not.
No.
And if you embrace the grayness, well, you actually want to harness the grayness of the AI's response because it usually thinks of things you don't think about. But and we haven't even spoken about, how AI can do a really good job of, for example, MCMC or Markov chain Monte Carlo simulation, which is an advanced analysis technique, which is usually reserved for people with MATLAB or Python skills.
Yeah, I haven't tried that yet.
Yeah, I've tried it. Again, going back to the first comment I made about you need to be on top of the basics.
Yeah.
AI does some pretty funny things that it'll use algorithms which are inappropriate or say, okay, I can see that this is what you're doing. So I've used a prior distribution for this parameter and everything else. You say, I didn't ask you to do that. And if people don't know what a prior distribution is, you're going to get biased results.
So again, it's the drunk Sheldon.
Yeah, exactly. So I suppose most of this conversation has been focused on talking about improving design, but whereas I think a lot of people are looking at AI to sort of be more analytical. Is that a fair call?
That AI helps people be more analytical.
Yeah, and analyzing your process, analyzing data, as opposed to generating a design. Is that a fair call, or do you?
I don't know. I think it is empowering people to be able to try things that they've always thought about before. Like, hey, wouldn't it be cool if this could happen? And then, if you're not a programmer or maybe you just didn't have enough time, it would just kind of like dissolve because how is that going to happen? But now, it's just it's an empowering way to be able to say, hey, I think I like this idea. I think I'm going to try it. And then you just hop on your AI and give it a try. Now, there's always, if you're going to release a product or something like that, or, if an app, you need to make sure that it's done with quality and you want to have the software people checking it out and everything. But I think it's giving people a lot more latitude to try the things that they wouldn't have been able to before, which is why I think it's exciting. And it's great to just dive in and try. It's one of those things you're going to learn by doing.
Right. I can't help but remember back when email started to come out as a concept. And I think people were saying email is fantastic. We don't have to write things down and photocopy and mail. This is going to save us so much time. But
I remember when email came out. Yeah.
Right. But what happened is when emails came out, people realized there was a lot less cost associated with sending messages. And so the volume of traffic went through the roof. and the quality of the traffic went down. If you had to write a report on paper or type it out, dare I say it, you put a lot of effort into getting the wording right. Some of the emails that get sent, and you have to read every single one of them, is just it ranges from memes to something very important. The amount of traffic has expanded to offset the apparent efficiencies of this email thing. And yes, it'd be crazy to say emails and electronic messaging hasn't, developed certain efficiencies in society, but it has generated a whole lot of useless, inefficient communication practices as well. I think the same thing's going to play to AI. If you know how to use AI well and you know how to use it for valid purposes, that's fantastic. But I sense there's going to be a lot of AI faff where people are using AI because it's AI, and all of a sudden they might lose focus of what they're there for. Just a thought.
And I think that's where the engineers are just more discerning about that stuff, about its use, about how to apply it. So I agree with you, though, and I like your analogy. Well, so if anybody has comments about how they're using AI, or if you're starting to think about an AI application only because it's enabling you to be able to do something you hadn't been able to do before, I would love to hear about that. How about you, Chris?
Love to, absolutely. I mean, there's no. I think AI is a subject for which there is no standard body of knowledge, nor will there ever be. It will evolve as quickly as we do. So it's an ongoing conversation as opposed to a search for a sort of one particular truth about how AI needs to be handled.
Yeah. So Chris and I are, elbows deep trying things. I'd like to know what you're trying. If you visit accendoreliability.com/go/SOR, Fred has a whole website set up for collecting comments. You can even leave a voicemail, and all the guests get all your comments and review them all, and they'll all get answered. So feel free to connect with us there. And any last minute thoughts, Chris?
No, I think AI is exciting, but it's also a powerful tool that needs to be used judiciously.
Yeah. Great close. Thanks, Chris.
Thanks, Dianna. Always a pleasure.
Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.